Hello everyone and welcome to our contribution to Tumuli and megalithic in Eurasia. Today we'll be talking a bit about GIS-based spatial analysis and how these might be applied to landscape archaeological studies. We'll be looking into a very interesting case study, the megalithic tomb of Cabeço da Anta, its constructive materials and their potential provenance. Cabeço da Anta is a funerary megalithic monument located right in the heart of the municipality of Proença-a-Nova. As most of the municipalities in the interior of Portugal, Proença-a-Nova administered borders are defined by natural features such as rivers, like Rio Ocreza, or mountain ranges such as Serra das Talhadas, Serra das Águas Quentes and Serra de Alvelos. It's fair to say that, in a way, these municipalities tend to correspond to somewhat coherent territorial units, in the sense that these features condition greatly mobility and accessibility and the communication between these different territories. But aside from its position in the landscape, it's important to look into the monument itself and where we're talking about it. So Cabeço da Anta is made up by a dolmen, a burial chamber with 9 slabs, each of which weighs around 2 tons. Most of these slabs are made of local raw materials, like metagravac, but one of them is made of quartzite, which is a point that we'll be turning back later. As for the mound, it's mainly made up by clay-like material with inclusions of quartz and a very significant and extensive layer of pebbles and boulders that are mainly from local outcrops. So, as you can see, despite all of the weathering that this monument must have suffered throughout the past few millennia, it's still an imposing monument with a very well preserved mound, which is exceptional in as far as Portugal goes, and it's easily mistaken by a natural elevation, as you can see. It averages around 36 meters diameter, and at the most of its height would be 4 meters at the center. It's possible that the builders made use of an already prominent landscape feature, a small elevation, a small plateau, and built on top of it, but regardless, the amount of argillous sediment that was remobilized is quite remarkable. And here we can see one of our trench pits. Our goal with this was to basically get a full profile of the mound structure and how it connects to the dolmen. In this stage you can see the internal layer of pebbles and boulders, most of them with very sharp edges, and after we removed it you can see the impressive amounts of material that can be found throughout its extension, and that obviously should be present all over the monument. But besides all of these boulders and pebbles that were most likely obtained from local outcrops, we can also point out a couple of elements such as this quartzite boulder, completely smoothed out by hydraulical action, that most likely came from a nearby river, a significant river, such as River Ocreza. This element in particular is important in the overall understanding of this monument, not only due to its potential provenance, but as well as its position in what we so far think is the alignment of the corridor, and in the way it was placed. It was intentionally placed as a part of a particular substructure with a couple of smaller stones holding it in position. However, the main feature that we wish to discuss in this presentation is the quartzite slab, as we can see here. That is part of the dolmen structure, while all of the remaining orthostatic slabs are made of metagravac, and it should be local, present in local outcrops or nearby riverbanks. This particular slab made up of quartzite, it's made of a material that can only be found at around 10 kilometers distance in a straight line. As you can see here, another image of it, and we can see it in profile, where its sides show the bedding planes and natural fractures that should be shared with the outcrop from which it originates. Okay, so this slab is made up of metaquartzite, and a rough estimate with its mass and its dimensions, we can point out an average weight of 2.17 tons. From a geological standpoint, it's fair to say that it comes from the American quartzite formation, lower to middle ore division in age, and this allows us to pinpoint where it could have come from, which is Serra das Talhadas, from Portugal Moron, where this outcrop is exposed, or from Termas da Ladeira in Serra das Águas Quentes. Now, we'll be looking a bit into these two potential sources and the GIS-based analysis that we conducted. Portugal Moron is a quartzite gorge in the Eurasia River where all of the ormorite quartzite formations section is naturally exposed. It's part of the border between Proença-a-Nova and Vila Velha de Roda. Its intense slope erosion was caused by river incision and gravital collapsing, and one of the main features from a landscape standpoint and the understanding of this potential source is the fact that it seems to have a prehistoric rock art, while it's still up to debate on its chronology, and it's around 9.2 kilometers distance in a straight line. Here you can see the natural outcrops and their fractures. And then the other option is Termas da Ladeira, a small quartzite gorge at Serra das Águas Quentes, which is located near the border between Proença-a-Nova and Nação, where the Armorican quartzite formation succession is also completely cropping out. The erosion is mostly gravitational, and from a landscape understanding viewpoint, where we weight these two options, it's an important water source still exploited these days. As far as linear distance goes, it's slightly further away than Portugal Moron, around 3 kilometers further away in a straight line. So, since we are conducting a landscape analysis and we are comparing two potential provenance places for the quartzite slab, we decided to use geographic information systems and spatial analysis that they allow us to conduct. And the thing is, when we are trying to conduct these analyses in archaeological studies, it's very important to keep a critical approach. I mean, we're not conducting these analyses for entertainment purposes. We want to answer specific questions, and we have to follow standard procedures and methodologies in order to be able to compare results and provide reliable data for discussion. And so the first step, the base, the foundation, is the selection of base data, which is the variables that we require to conduct this analysis. In this case, we modulated the territory, recurring to altimetric contour lines and the hydrological network. And we use these two variables to create accumulated cost surfaces through the application of an algorithm that we'll talk a bit further. There are other spatial variables that could be used, obviously, such as vegetation cover, trees, but the thing is, we can't really precise where those elements would be 7,000 years ago. So when we're working on an archaeological case study, we need to make sure that the coordinate systems are obviously compatible, but we also need to take into account the space-time rigor and accuracy. This means that we have to use reliable data that is contemporary to what we're studying. And so, for instance, when we're looking into these two variables, we are obviously going to edit out everything that are like massive dams that are conditioning and altering the hydrological distribution and that are hiding certain altimetrical features that become sunken because of the presence of these dams, and also motorways and other anthropic contemporary features need to be edited out. The other aspect that we need to consider is the selection of appropriate technical procedures. So if we're analyzing, in this case, accessibility and visibility, and we're looking into these two phenomena that go hand in hand in human experience, we need to choose technical procedures that fit the analysis that we want to make. And in this case, we chose the MADO, which is the Spanish acronym for Modelo de Acumulación de Desplazamiento Óptimo, which roughly translated means accumulated flow flux model. And the other one that we chose is the least cost paths. So least cost paths are a special analysis in which we select 2 points, and we ask the computer, the GIS, to calculate the least cost path between these 2 points based on our terrain and the algorithm that we apply on it. And so it draws us the best path to go from point A to point B. The MADO, however, works differently. We give it 1 point, and the MADO will draw us all of the paths through which movement is easily practiced. Basically, the best path to go from or to that point. But we only choose the first point. All of the rest is modulated by the algorithm and the GIS. And we chose these 2 procedures because they are the ones that suit better our case study and the questions that we are asking. So with a good understanding of our case study and a good understanding of the theoretical principles of these procedures, we can select the most appropriate tools to conduct our analysis. Okay, so with that being said, these are the least cost paths that we obtain in our analysis between Cabeço da Anta and 2 potential sources, Termas da Aldeira and Portugal Moron. And before we go a bit further into this, I need to point out that we didn't use an algorithm made specifically for the transportation of a 2-ton quartzite slab. Basically, we do not have enough information to model such an algorithm. We do not know what kind of technology these communities had available, whether they had sort of vehicles for terrain transportation or transportation through water. We do not know how many people were involved, and we do not know even if there was pre-existing paths that could have been used to facilitate the transportation of this slab. So what we did instead, and this is basically a golden rule for this kind of spatial analysis, is we used an algorithm, which is Tobler algorithm, which is basically a widely used algorithm for modeling human movement by calculating the correlation between slope and speed for a human to walk. And basically what we want to obtain through this is the paths that these communities would walk on their day-to-day basis, and the paths that would be best suited for their movement throughout the territory. And using such an algorithm, a simple algorithm, a basic algorithm, means that we are not conditioning the analysis with variables that are specific to certain conditions. We want a global model, one that is used for several situations and that allows us to get a better understanding of what would be the relation between the territory and these communities, almost in an organic fashion. And comparing the least cost paths that we obtain, and we can see here there is a small diversion that I'll explain a bit further. Basically, between this path and this path, the difference in time spent, because this is an algorithm that calculates the least cost paths based on the time spent to cross the distance, is pretty much the same. there is a 10% difference where thermal data is a bit further, but overall this is not significant significant time difference that would warrant the choice of one point over the other when we're talking about the transportation of a 2-ton slab. And here we can see a bit of what the terrain looks these days. This picture was taken between Serra das Talhadas and Serra das Águas Quentes after the 2017 forest fires, and it gives us a very clear picture of what was the terrain like that would have to be crossed to carry such a slab, such an heavy element. It's a very irregular terrain marked by the drainage network that is typical from a shale substrate, and it has several small water courses that will obviously make the trip all the most difficult. So as you can see here, we also decided to calculate the profile to get a better understanding of the distance crossed and the elevational shifts that occur throughout this trip. And as you can see here, there is obviously the crossing of a few water courses, which would make the trip all the more difficult, and probably had to be done in a time where the water course was not as strong during the summer and such. But overall, it's a very, after going down this hill, it was all the way up to get to the monument. And here we have a very somewhat similar situation with two major crosses and water points, but overall a very ascending route throughout this territory. Now, the reason for the diversion between that we saw a bit ago was that in both cases I calculated the least cost path from a point selected on the top of the natural feature and from the bottom, and the same was done here, but in both cases the result was the same. There was no splitting of the path. In the case of Portugal Moron, however, it was not like that. This is the path that we obtained calculated from the highest point of this feature. Now, when we look at the path calculated from the bottom part, this is the result we obtained. And as you can see, there is a small portion of the trip that is made through water, according to our algorithm, but through water means alongside the riverbank, basically, and then there is a very steep ascending, and then the terrain meets up again with what we saw previously. And here we can see the image of Portugal Moron, which is a very impressive geological feature, a geological monument, and where we believe that the slab could have been obtained. So the other analysis that we conducted, the MADO, was basically because we did not get a clear response for our question when we calculated the least cost path. So when we calculate the least cost path, we give the GIS a starting point, Cabeço da Anta, and we give it a destination, whether it is Portugal Moron or Serra das Águas Quentes, and we ask it to calculate the least cost path. The MADO, however, we do not condition it the same way. We just select a starting point, which in this case was Cabeço da Anta, and we ask it to calculate the best path to get to it or to grow from it. Basically the paths of least resistance that are more suitable for movement and for mobility. And the result to us was extremely surprising and actually a bit enlightening on how these communities related themselves to the landscape. Basically these are communities that are very knowledgeable of the territory that surrounds them, and they develop a relationship with it that it becomes sort of a landscape where their monuments are distributed throughout it, and in a way natural features merge with anthropic features and constructions. And I'm dispersing a bit, I'm sorry, but when we look at a model like this, and the first thing we need to point out is that there are paths both to Portugal Moron and Termas da Ladeira, and both of these paths come out naturally, as I'm saying, because the only point that we put on the model is Cabeço da Anta. So both of these points that we thought could be potential sources are both part of the organic movement network for this territory, starting from Cabeço da Anta. The other important point that surprises us is the relationship between this movement network and the distribution of contemporary sites to Cabeço da Anta. So these blue points represent contemporary archaeological features, and as you can see, there is a very close relationship between this network and the distribution of this site. And what this tells us basically is that besides the impression that Cabeço da Anta represents here a very central place in this territory, both of these sources were known to the builders, were most likely known to the builders of this monument, because both of these points are important crossing passages to other territories. Crossing Serra das Talhadas brings us to the Peneplanície de Castelo Branco, and crossing Serra das Águas Quentes brings us closer to Mação, and to a territory also rich in contemporary features, Cabeço da Anta. So this was a territory that, despite natural features that acted like borders, certain passage points were used and made influences and contacts possible. And the fact that the slab came from each of these points, one of them, that was placed simultaneously in an area that acts as a border and as a gateway, is particularly relevant and important from a landscape standpoint, and how these communities looked into their world and decided to take part of it and put it in a monument that, due to its engineering, due to its construction, is one of a kind, and one that will certainly play a very important role in their structuring of the world as they saw it, and of the territory, which basically they take it and they make it their own landscape, and of their ancestors basically, and all of what it meant to these communities. This is a bit of a zoom in on this network of movement and the relationship between these all of these elements, and how they come together in the end. So I thank you everyone for your attention, and I hope that despite this pandemic, that everyone is safe and working as well as it is possible. Thank you for your attention, and take care and stay safe. Thank you.